Video we're going to be looking at geometric sequences, and geometric sequences are going to feel a little bit different than arithmetic, but we're going to follow some of the same beats out there. The big thing with a geometric sequence is obviously we're talking about a common ratio. So this is how we find our nth term when it comes to geometric sequence, and it's, again, hopefully you'll see it's very reminiscent of just our exponential value function. And again, you'll notice that we've just shifted everything to the right to ensure that instead of our y-intercept being term 0, we want t1 to model our y-intercept there. We want that to be reflected at 1 and not at 0. So that's why we shift everything to the right. Okay, we still use the first term of our sequence to help model the rest of the function, and we still have n being the number of terms. R is our common ratio, and to get our common ratio, what you're going to do is you're going to just take some value right there. So you'll take some n plus 1, and then you'll divide it by the previous term. So that's what I mean by that is, you know, whatever n is, you're going to, whatever n is, I should say, you're going to it's going to be the divisor of the next term, because you're trying to figure out what that R value is. What do you have? In other words, what are you multiplying by to go from n to n plus 1? To go from n plus 1 to n plus 2, whatever that next term of the sequence is, what do you multiply to get there? Okay, and in this case right here, all we're doing is we're saying, hey, 4 divided by 2 is 2. 8 divided by 4 is 2. And in this case, that just means that our common ratio then is 2. I'm going to be multiplying by 2 every single time I'm incrementing along that list. Okay. An important note to make here is that geometric sequences can have R values that are negative. Okay, so and that's kind of the biggest difference between them and an exponential function. Whenever we had exponential functions, and when you think back to a b to the x, b was always greater than 0. Okay, but now, and usually it wasn't equal to 1 either. But in this case, we can have both of them, right? Like, you can have an R value that is negative. So let's just take a little look-see and figure this out. So if I call this n plus 1, n plus 2, and so on and so forth, negative 6 divided by 2 is going to give me negative 3. Okay. 18 divided by negative 6 gives me an R value of negative 3. And then so on and so forth. So spoiler alert, you're going to get the same thing. Negative 54 divided by 18 also gets you an R value of negative 3. So what we're doing here is we're incrementing along as we are multiplying by negative 3. So multiplying by negative 3, multiplying by negative 3. Which in turn means that our little term n here, so we'll say term n is 2 and then negative 3 raised to the n minus 1. This as a function, this is not a continuous function, right? Like, if you were to plot this out onto a graph, like, you're going to oscillate between exponential growth in the positive and the negative side as you increment along. So these are not drawn as continuous lines like you would have back in the previous semester here. So this is a true, just discrete equation. And the other reason too, just in general, like, that also applies to arithmetic sequences as well, because your n is some integer value. And it's kind of it's implied, but in some textbooks and some profs, you'll actually see them say, like, n, sorry, not even an integer. It has to be a natural number. N is a natural number because you can't even have 0, right? Like, you are literally just saying n is can be equal to 1 all the way to positive infinity, but it has to be some whole number, or some natural number, because you can't have 0. So let's do some practice here. Determine the indicated term. So we're given a ratio here, and we're given a sequence, and I want to know what term 12 is. So first thing I'll do is actually figure out how I define this sequence, this geometric sequence. So how do I go from 2.8 to 7? So off to the side here, I'm going to say, okay, 7 divided by negative 2.8. And don't worry, I can't do that. So I'm just going to get out trusty Mr. Buttons here. So 7 divided by 2.8 gives me 2.5. So it looks like 2.5, and I'll do a double check there. So negative 17.5, negative 17.5 divided by 7 gives me 2.5. So I'm going to have 2.5, or negative 2.5 as my common ratio. Then n minus 1, and my first term is negative 2.8. I'm looking for term 12, so I'll go term 12 is equal to negative 2.8, negative 2.5, raised to the 12 minus 1, or term 12 is equal to negative 2.8, negative 2.5 raised to the 11. Doesn't matter whether it's inside or outside the brackets. So I'm going to go negative 2.5 raised to the 11th power. It's going to give me a big number. Yep. And then times negative 2.8 is going to give me approximately, I'm going to have to round here, 66757.2. Okay, let's try this one right here. So again, how am I going to define this one? So I'm going to have to say, okay, negative 3 divided by 4 gives me 0.75. Does 2.25 divided by negative 3, which should be negative 2.75. So I'll do a double check. 2.25 divided by 3 gives me that negative 0.75. So negative 0.75, I've checked. So my common ratio is 0.75, negative 0.75. So I'll say Tn is equal to 4 onto 0.75 negative, and then my R value, or my will be n minus 1. Then I'll say term 7 then is equal to 4, negative 0.75, 7 minus 1 is 6. And then I'll say, okay, 0.75 raised to the 6th power is going to give me a positive number. And then I'm going to times it by 4. And that's, again, I'm going to do a little bit of rounding here, 0.7119. Now, if I want to be a good math student, what I would actually do is I would probably write this as a fraction. And I would say 3/4 raised to the 6th power. And then I could write this actually quite precisely by saying 4 times 3 to the 6 divided by 4 to the 6. That would be probably a little bit of a better way of representing it right there. And look, I can even cross out one of my 4s. So this will be 3 to the 6 over 4 to the 5th. I can do a little check there. 3 raised to the 6 divided by 4 to the 5th. It gives me that same number. Excellente. And there's nothing else I can do there. Yeah, there's no common factors. So that right there is probably a little bit of a better notation. But practice, determine the general term. So here we're given two terms in some geometric sequence. By the way, you'll always be told if it's geometric or arithmetic, because we're in the geometric section. It's implied that all these examples are going to be geometric. So I know, again, I'm going to think about this as 5, negative 819.2 and 3, negative 12.8. So what I'm going to do is I'm going to say, hey, negative 819.2 is equal to 5 onto r n minus 1. And then I know negative 12.8 is equal to, by 5, I of course mean T1, geez Louise, T1. And then my n is actually 5. Geez Louise, old Savoy. 5. And then negative 12.8 is T1 onto r, and this is going to be 3, so 3 minus 1. So I can simplify this as 819.2 is equal to term 1, r to the 4th. Negative 12.8 is equal to T1, r squared. And then I can solve for T1, so I'll say negative 819.2 is equal to T1 divided by r to the 4th. Negative 12.8 divided by r squared is equal to T1. You could solve for r in each case, but you'll just end up like square rooting and fourth rooting, which is going to give you a bunch of irrational numbers. So I would say it's just easier to do this. And notice, since we're talking about the same sequence, I have T1 is equal to T1. So I can then say, by extension, 819.2 over r to the 4th must be equal to negative 12.8 over r squared. So I'm going to move this r over there, and I will divide by 12.8, which is going to give me negative 819.2 divided by negative 12.8 is equal to r squared. I get that r squared because when I multiply by r to the 4th divided by r squared, I'm just going to subtract those exponents, and I'll get r squared. So 819.2 divided by 12.8 gives me 64. Did I 819.2? Oh, yeah, that makes sense because r squared is 64. R squared is 64, which then means r is going to be equal to 8. Then the question, we're going to have the question, should that be a positive or a negative 8? And this is the actual interesting part here. Because I have two negative numbers, Interesting. I'm going to actually have to solve for T1 here just to make sure, because I'm not sure I can actually just say it's going to be negative right off the bat. Because the whole thing might have started with a negative number. So interesting. Okay, so I'm going to solve for T1 here and see if it's going to be, because right now all I know is that it either has to be plus or minus 8, and it's going to come down to what term 1 is. And just to really explain what I'm thinking here, I'm thinking, okay, if term 1 starts as negative, I can have a positive R value because every time I multiply by a positive R value, it's going to keep being negative. But if term 1 starts as a positive number, then I have to have a negative R value in order to guarantee the fact that it's going to get me negative values for term 3 and term 5. That's what's going through my head now, just as you guys are doing, because I just pull these questions randomly. So term 1, so I'm just gonna plug this value. I'm gonna plug it into either one and see if it's gonna work. So if I go negative 12.8 is equal to T1 negative 8 squared. Does that give me the same thing as negative 819.2 is equal to T1 and then negative 8 and then to the 4th power. Okay, so this is going to be negative 12.8 over 64, and this will be negative 819.2 over, that's going to be a big number, 8 raised to the 4th. It's going to be 4096. And actually, this will work. Okay, yeah, so it can be either positive or negative. Look at that. I'm proving it to myself there. 12.8 divided by 64 gives me 0.2. And 819.2 divided by 4096 also gives me the 0.2. Yeah. So actually our R value can be positive or negative. It depends on what our first term is, whether or not we treat our first term as positive or whether or not we treat our first term as negative. We're not given enough information to be able to say it's definitively one or the other. Let's go do another one here. In bacterial cultures, all bacteria go through mitosis to reproduce, during which one cell becomes 2, 2 becomes 4, and so on. So 1 to 2 to 4, so on. Suppose there are 10 bacteria originally present. Oh, okay, so we start with 10. So 10 must become 20, 20 must become 40, and so on. Determine the general term that relates to the number of bacteria. State all known variables. So this is actually going to be pretty straightforward. So I can just say Tn is equal to 10, 2, and then n minus 1, and where n, does it tell us, so is there 10 number, 10 is, so n is just going to be how long it takes to reproduce, doubling time, I'll say, doubling time. T1 is going to be 10, and that's the original amount, and 2 is our ratio because it's doubles. And that would be it. Yeah. So if I wanted to figure out how many there are after, let's say that it takes a day to double. So then, this is day 1, this is day 2, and so on. So then I could say, okay, on day 50, how many bacteria are there? But that was a pretty straightforward question. A photocopier can be used to create enlargements or reductions. If a photo is 25 centimeters and the smallest size a copier can make is a 67% reduction, by the way, that means our R value then is going to be 0.67. What is the shortest possible length after 5 reductions? So we start with 25, that's our term 1. And I know then that I'm going to be multiplying by 0.67. So I'm going to do that 5 times after 5 reductions. So reduction, actually, this is actually interesting. So term 1 would be the first, I guess, kind of depends on how you want it. So term 1, there's no reduction. So term 2 is the first reduction. Term 3 is the second reduction. So we'd actually want term 6. So express this answer to the nearest centimeter. So what I'm going to do is I'll write this as Tn is equal to 25, 0.67, and then n minus 1. So I'm going to do Tn is equal to 25, 0.67, and this is going to be term 6 I care about, to the 5th power, because I want 5 reductions. So 0.67 raised to the 5th power times 25 gives me approximately 3.4 centimeters. Very cool. We did an example like that already, and we got some practice. Okay. Yeah, so that's it for this video, and I'll see you guys in the next one when we do series.